our attention with triangles needs to change from just dealing with side lengths, right? That's not the only intention with triangles, okay? You can see when I pose a question like this, which one do you want to work with or push? Which triangle or incline do you want to push the box up? You can see how there's kind of two factors going on there, right? And that's because we're dealing with triangles, and triangles have side lengths and angles, okay? So it turns out it's actually better to push just purely based on how far you're, well, the combination of the two, just on this scenario, it's better to push up this incline than the other one. Okay, whether or not you believe it, okay? I've done the math on it. Okay? Does anybody have any questions? So what we're going to spend the rest of the today on, we're just going to go down, we're just going to like, our concentration is going to shift from just dealing with side lengths, right? So we're going to mix in angles and side lengths now, okay? So we have this thing, it's called the tangent ratio, okay? And basically what it is, it's like our incline question here, right? And what we're going to say is, okay, we're standing down here with a box, right? And like we're going to try and push it up. And what you can see here is that it's broken, it's new words, like opposite and adjacent are new words for you from a mathematical standpoint. But they, you know the meaning of them actually, relative to the triangle. And we just finished doing it. So if you look here, if I change the word, like, I don't know, if I change the word tangent to slope, and that was equal to rise over run. Well, let's just take a look at the word rise. Where's the word rise is relative to this down here? Well, it's opposite. Where is it on the triangle? Oh, it's where the rise was. Opposite. All right, well, that's kind of interesting. This is what I kind of mean by the fact that you guys know how to do this almost already, just from our work with lines and just what we just finished doing at the top here, right? The other piece is how far along did we go, or the run. That's the adjacent. Adjacent is down here in the run position. Okay. The nice thing is, or kind of the bridge between both of these concepts, is this whole time we've been calling this here the hypotenuse. Okay. Now, there's one other silly looking thing here that you guys probably haven't seen before. It is this right here. What is that? This is how you say this. This is how you would draw it. Okay, it's like a circle. It's a continuous circle. You draw a line through it. It has a name of theta. Okay. It also has a sister named, oh, how do you spell this one? I think it's spelled like this, phi. Okay, and then there's gamma, beta. These are all these are Greek letters. Okay. What do they stand for? They stand for an angle. And your first clue should be, okay, when I see it, if I zoom in here on this, it's theta, and then this little symbol here, that means degrees. Right? So it's just another math symbol. Okay, but they're predominantly used for angles. Okay, so what you're going to see here is like, okay, just a way to decipher between, okay, a normal English language O and A versus if I'm looking for an angle, I can solve for theta, phi, beta, gamma, alpha. Alpha's in that list too. Is that alpha? I think so. There's a whole bunch of them. Okay, they're just typically used for angles. What I'll use is probably most of the time will just be these two. Okay, so what does this all mean? Okay, well, it allows us to, like, when we say solve a triangle or a particular triangle, it means tell me what all the side lengths are and what all the angles are. Okay? So the tangent ratio for a right angle triangle is defined as the opposite side length divided by the adjacent side length. Okay, that's what we just saw. You could substitute all these words out for being tangent ratio. We could say that represents slope. I'm just trying to figure out where to write this. Right? Slope for a right angle triangle is defined as the opposite side. We could draw a line through that and say that's the rise divided by the adjacent side length, the run. You guys know what this is. And then it's just a ratio, right? Or a fraction. Opposite and adjacent. Rise over run. Okay? The one way I always remember this, if I'm standing, okay, this is where I'm standing right here at theta, right? Like I'm like standing in this corner, or I was trying to push the box here. If I looked directly across, that would be opposite of me, right? Opposite, because I'm standing there. It's always so. If I drew a isn't rise over run. No, rise over run is this, right? So let's just hear for a sec, Ethan. Yeah, that's a good question. It's a good question. Here's what I'm going to do. I'm going to draw you a line. Okay, I'm just going to draw you an arbitrary line. I'm going to make it up. Okay? We're going to say, here's my line. Okay? How would you figure out the slope of that line? Well, you would go, okay, slope, you tell me, slope was rise over run. Okay, well let's just figure out, let's just pretend here we've got two nice points. Right? We got our y-intercept there, and we got a nice point up in the other part of the graph, right? We're going to say, okay, well, rise over run. Okay, well, we've got, you tell me what shape I'm about to create. Here's our run, right? Here's our rise. What do we get here? What is this? What shape is this? It's a triangle. It's a special kind of triangle too, right? Because these two things meet at a 90 degree. So if I was standing, I could pretend to be anything, right? If I'm standing down here in this corner with the angle theta, and I look across, I see rise. That's opposite. That looks like right. I'm going to write rise. Okay, does that answer the question, Ethan? When you look at the slope is comprised of an x piece and a y piece, right? The y piece is the up and down, and the x is the left to right. Right? Rise over run is how we find slope. And I think we did, right before the break, we had an activity, and maybe I'll try and find it before today's lesson's over, where I gave you guys a bunch of pictures, different triangles on a grid, and we had to find the slope. And I was trying to use the triangles to get you guys to answer how steep is the triangle. I'll find that after. I remember doing it, okay, and I'll pull it up as soon as we finish this video, okay? So, I'm trying to remember where I was here. This is just fancy math jargon for saying this, what's in this yellow box. Okay, the other thing we didn't talk about here is, okay, great, we have rise, and conceptually, if I'm standing in the corner and looking across, that's opposite. That's easy, right? Where those words came from anyway. But what does this word adjacent mean? Does anybody have any, like, a definition of the word adjacent? Do we have any idea what that might be? And like, you could go into like Google and type it in, and I'm sure it would give you some other words. Opposite is always opposite, right? Opposite is going to be like you're directly across, or opposite. I guess across could be another word for opposite. That's going to be like across. We could use that word, right? That doesn't across have two C's. That's better. You guys, now you can see why I like numbers. I don't really do well with words. Okay. Adjacent. Another word for adjacent is beside. Okay, this is how I kind of remember it, or how I learned it anyway, or locked it into my mind. Okay, if I'm standing in a particular corner, like say for instance down here, I always have this kind of angle of interest. That's what I mean by kind of standing in that corner, right? If I look across, I can see 6 is going to be the rise, or we could call it, we can try and move away from this notion of it being the rise. We can call it opposite. It's opposite because I'm standing directly across from it. Now, while I'm standing right here in this corner, directly beside me, or adjacent, is the 8. Okay, does anybody have any questions with that? These are just kind of like synonyms for one another, okay? Opposite, across, adjacent, beside. Okay, that's how I've remembered it. Okay, so if I were to go into this now, if I was trying to write remember I'm going to try and pull you towards this terminology now, the tangent ratio. If I was going to pull you towards writing the tangent ratio for each of these, right? I'm going to say, I'm going to get rid of some stuff here too, just because I need some room. I'm going to say, I'll do it in blue so you guys can see, okay? I'm going to say, okay, how do I want to write this? Tan of theta will equal opposite over adjacent. This is what you're ultimately going to write, okay? Or rise, why did I spell rise with an S? Over run. So you just fill in the numbers, right? What's opposite? 6. What's adjacent? 8. Okay? That's all I want you guys to do for right now, okay? Just on this page. Okay? Then we can do the green one. That's going to be tan theta is equal to, what's opposite? There's opposite. There's adjacent. Opposite over adjacent. We're just filling the numbers now. 3 over 4. Okay. I'm not actually quite done with this yet. Just going to put boxes around everything, and then I'm going to show you guys something in a sec, okay? What about we'll use purple for this one. Tan theta here is equal to 9 over 12, right? Because this is opposite. And this is adjacent. Well, something interesting happens here, right? You can see each of these like have different numbers, right? Like 6 over 8 is different from 3 over 4 is different from 9 over 12. So you would expect different answers there, right? Or different, you could even say different slopes, right? right? Because these are a measure of, if these were like lines, would you guys tell me, oh no, these are the numbers are different, so the slopes must be different, right? Or another way of asking this would be like, which of these would you like to push the box up? Right? That's your question. Here, like, which one's steepest? Well, the steepest one would be the one with the biggest numbers. Does that make sense? Is anybody like catching what I'm doing here? Sometimes I think one of the weaknesses for everybody, right? I even see it in my own like it's just understanding one fraction bigger than another or smaller, right? Can have a hard time like measuring in the reading a tape measure. Sometimes you can have, okay, what's bigger than what? It's a little bit hard sometimes when they get like 30 seconds versus an eighth, right? Like how many of each, right? If you have 30 seconds versus 1/8, which one's bigger, right? Sometimes I have to think sometimes, right? Same thing here. This is all I'm asking you to do. Some comparing fractions with one another, right? Comparing slopes. My question is which one is the biggest, right? I think everybody's tendency would be to go to the one that says, oh, it's the big number one. Well, turns out, let's see what happens. If I were to take my calculator, right, and what I'm going to do here is say, okay, what's 9 over 12? We can type that into our calculator and see what happens. What happens? 9 divided by 12. Oh, 0.75. Okay. Well, let's do it for the blue one. Uh, 6 divided by 8. Oh, that's weird. What about the green one? 3 divided by 4. Why? What is going on here? Why are all three of these the same? Why is this not steeper than the other ones? It's bigger. Why? What's going on? Does anybody have any ideas? How would I have known that all three of these would have been the same right from the get-go? Same angle. Same angle. Same angle. All of these are 37 degrees. What is an angle? An angle is a measure of how steep something is, right? Because these all match, there better be a relationship between the angle that you're seeing and the two side lengths that are attached to it. There better be a relationship, right? That relationship is basically the study of trig and triangles, okay? And the one we're concentrating on at the moment, one of the relationships, is the tangent ratio. The tangent ratio is telling us that the angle in the corner, theta, is directly connected to the opposite side length and the adjacent side length. That's what it's telling us. If there's a direct connection, then I can find any of those three pieces of information. I can find the angle, I can find how tall something is, or I can find how long something is if I have two pieces of the information, right? So if I look at this tangent ratio that we wrote up above here, tan theta is equal to, say, I'm going to move away from rise over run. I'm going to say opposite over adjacent. If I know two pieces of this information, if it's opposite and adjacent, I can find the third being the angle. If I'm given the angle and one of the side lengths, I can find the third. Doesn't matter which of the two I'm given. If I'm given the adjacent, I can find the opposite. That is the tangent ratio. Okay? There is a like a direct relationship between the side lengths of a triangle and the angle that they produce down at the bottom. That's what tangent ratio does. Okay? Does anybody have any questions? So I'm just going to relate this back to something else here. And this is what we talked about this morning. I think as some of you start to get your licenses, I believe one of the questions on one of the tests might be something related to the grade of a road, right? So maybe understanding this might get you the question right now, right? So I think you guys are getting close to getting your license, or at least your G1s, right? Right. Okay, so the grade is a measurement of how steep something is, obviously, right? Because you can see with the triangle and the truck on there, right? It's 25% grade. Okay, what that actually means is, if you take a look here, it means that for every 100 feet, if I'm just looking at the green one, every 100 feet of road, it's going to increase in height by 5 feet. What happens if you divide 5 by 100? Like if I were to find a percentage, or in this case, if I was to do, if I got like 5 out of 100 on a test, your mark would be 5%. Okay, if you saw this grade sign here, this could be a multiple choice test on your driving test, or a multiple choice question on your driving test. What does this sign mean? It means every 100 feet you drive, the road drops off. How am I going to draw this? Every 100 feet you drive, you drop 25 feet. That's what this means. Okay, it's purely a measure of rise. In this case, it's falling, right? Which is going to have a negative rise in this question because we're going down, right? And we're going to have a run. Okay, so what I'm going to do down here, okay, I'm just going to answer the second part of this question. I'm going to use it to introduce. You get the idea here with all of these, okay? They're all going to be the same thing, same calculation. You're just going to have obviously the angle here gets bigger and bigger. You can see it. You can visually see it, right? It's being able to recognize without having to draw these triangles that the angle is getting bigger as you go down the page. Okay, so what I'm going to do here, I'm going to do the calculation based off of this question. What does the 25% grade mean? That's the explanation I just provided here, right? For every 100 feet that you drive down this hill, it's dropped 25 feet from like the original height. That's what this means, 25% grade, right? And in Ontario, I don't know what the regulation is, right? But there are certain instances for different things, such that, like if you were building a ramp, for instance, it wouldn't be allowed to exceed a percent, like a certain grade, right? For wheelchair access or whatever reason, right? It can't be too steep is basically what it means. To do that, it says you can't exceed 10% grade or an angle of this, right? For building a ramp. So you're going to have to change your dimensions such that you would know in that question what your theta is. You'd have to change what your rise and run are to lock this in. Well, if you know how high you have to go up, right? Well, then you know your rise. You just solve for the run. Okay, we can use tangent ratio for that kind of question. There might be one down here. I don't know, or I can find one and we'll make one up for tomorrow or something. Okay, we'll do one of those. But for right now, let's figure this out. What is the angle of this hill? So I'm going to redraw this triangle down here. Okay, we're going to go down 25 feet. I'm going to make it a little bit bigger. Right? So remember, this is your starting height, right? This is where you started. And then you're going to drive your car down the inclined road. What angle are you driving at is the question. Well, the angle is over here in the corner, theta. Right? And remember, 25% grade means we're going over 100 feet and down 25. Okay, does anybody have any questions? I'm just going to actually calculate this theta now. Okay, I have two pieces of information. I'm going to use tangent ratio. So I'm going to write tan theta is equal to rise, say negative 25 over 100. So we're going to say, okay, I'm going to get rid of the negative, okay? We don't need to worry about the negatives. Trig is kind of magical that way. Kind of magic. Takes care of the negatives for reasons you guys don't necessarily need to know, okay? You're just trying to solve. You don't need to worry about the negatives. Okay, 25 divided by 100 is 0.25. All right, great. We have tan theta equals 0.25. Does that look right? Is the angle supposed to be 0.25? I don't think so. That doesn't seem like a lot. 0.25 is something like this. I don't even think you'd be able to see 0.25. It's tiny, 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 right? Like 1 degree. Think about 1 degree. Like even, yeah. This doesn't make any sense, is the issue, okay? Which probably points you towards, if you remember looking at Pythagorean theorem, and we got this astronomical number relative to our three side lengths. Probably not right. So we're going to have to do some more work. There's something that we're missing. Same thing here. Our answer doesn't seem right here. So there's probably something else we have to do, okay? There's something else you're going to have to do, and I'm going to post this on Minds Online. You're going to go down, and you're going to use something that we call a trig table, okay? Okay, a trig table breaks down, and for right now, you're only worried about, I know this looks like a lot, it's not that big of a deal, really. I think this is really cool and easy. I never saw this in high school. I'm only worried about this column for right now. These two columns are the same column, but it's tangent, and I know that's the tangent. We're going to call that the tangent column because tan is opposite over adjacent. Well, this column is opposite over adjacent. Okay, so here's the cool thing about this table. I think this is really, really cool. What you can do is you can go find, you see a whole bunch of decimal values all through this table, right? And on the left side, you see degrees. It counts up, right? What are we interested in? We're interested in theta. Theta is measured in degrees. We said that at the beginning of this lesson. Okay, well, okay, this is obviously the column that I'm looking to get my answer from. What does that mean? There's 90 answers here. How do I pick which one it is? Well, if we go back up, we saw what the ratio was supposed to be. What opposite over adjacent was equal to. Opposite over adjacent was equal to 0.25. All right, well, if we go find 0.25 in my opposite over adjacent column, it looks like it's right here. I know it says 0.24, but we can round that up, 0.249. That looks like 0.25. Well, what's the angle that's associated with that? 14 degrees. Right? Which means, okay, we go back up. Theta equals 14 degrees. All right, what does that mean? Well, it means, therefore, the road goes down, remember, because it went down because we're going down a hill, right? Goes down 14 degrees. That's what 25% grade means. Does anybody have any questions? I don't know. I thought, like, I'm pretty happy with this lesson. This is a lot better than trying to just give you the tangent ratio. I think I don't know. I feel better about the way that I've delivered that relative to other ways that have been done in the past. Okay, I haven't taught you how to solve any questions yet. Just kind of giving me a little talk here and like trying to relate everything back to one another, right? For right now, you don't have any homework with this lesson. Okay, I think I've put you, at least I feel good about where I've kind of left this. And I will teach you tomorrow morning. We will go over how to use this now to actually solve triangles. I kind of did one right there, right? But I will show you how to solve triangles like this. Okay? And we'll just do a whole bunch of them. Okay? So that'll be tomorrow, okay? So for right now, I think your homework for right now, because I'm not going to give you homework this lesson, is to your summative tonight. That's a lot of work. And you have that formative 7 out there as well. Okay, so I'd like formative 7 I gave till tomorrow at midnight. Okay, so you have till tomorrow to work on that. I'd like everybody's summative done tonight. Okay, that's what you can work on tonight. Okay, so we'll stop